I'm going to demonstrate and explain the process of uncovering problem structures, as well as the process of representing relationships between quantities using strip diagrams. So the first thing we're going to do is take a look at different types of problem structures. Here you can see that we have 4 different types, and the first one we're going to take a look at is the join structure. Alright, here we go. If we were to have a problem where we knew the starting point, we knew that something was joined to it, and then we had a result, or any combination of those, then we know that we are going to use the join structure. As long as you know that you are joining an amount to something, then you know that we're going to use the join structure. Okay? Separate structure is very similar to the join, except for this one we use whenever we have a starting amount. We're separating out something for the change, and then we find our result. So any combination of the start, the result, and the separating of an amount, then you know we're going to use the separate structure. We also have the compare structure, which is used when we're looking at 2 different sets of things, and we're also taking a look at the difference between the 2 sets. Okay, so this is all about comparing 2 different sets of things. Now on to our last structure. It's part, whole. So when we have a problem where we're looking at 2 different parts of something and also taking a look at the whole amount that is created from the 2 parts, then we know we are dealing with a part, whole structure. So let's begin by taking a look at problem 10. Our first problem that we're going to take a look at. So, the problem says there are 10 students in kindergarten. 3 students are boys. How many girls are there in kindergarten? Alright, so now you can see that I've listed the 4 different structures here, and I want you to think about what we discussed about each one of those and decide which one you think best fits this problem that we have here. So I'm going to discuss this problem some more. So we know that there are a total of 10 students. We know that 3 students are boys, and we know that we're wanting to know how many girls of those 10 students are in kindergarten. Okay, so let's start over here. Separate. We know separate is when we're taking out or separating some from our total, and we didn't discuss anything about separating out an amount. Okay, so that's not going to be it. Part, whole, when we're looking at 2 parts and trying to find the whole or comparing those. We're not really talking about 2 parts here, so that's not going to be it. Join, this is when we're joining an amount to our starting, so that's not going to be because we're not joining anything here. So this leaves us with our compare structure. Compare structures when we're looking at 2 different sets of something and deciding the difference between them. So that's the structure that will be best fit for this problem, because we have 2 sets that we're comparing. We're comparing boys to girls and looking for the difference between them. Alright, so here's the compare structure when we're looking at 2 different sets and we're trying to find the difference between them. Okay, so have a worksheet compare set up right here that we're going to take a look at, and the first thing we're going to do is uncover this problem structure. Okay, so we know that we're comparing 2 different sets here. One set is the boys and another set are the girls. Okay, so we need to find our large set and our small set, and then we're going to look at the difference. So we know that there are 10 students in kindergarten total. So our total number of students in kindergarten is going to be 10. We also know that there are 3 boys in kindergarten. So we're going to estimate about here to be 3 out of 10. Then we're going to go ahead and put 3 boys here so that we know that that is the amount for the boys. And so you can see that this is going to be the small set. So now we're looking for the large set, which would be the girls. So we're going to go ahead and add our 3 over here. And now we're going to find the number of girls in kindergarten. Okay, so now we're looking at our 2 different sets of things, which are the 3 boys and a certain number of girls. Okay, so we're comparing those 2 numbers and trying to figure out how we can get those to total out to 10. So what we can do to figure this out is go ahead and use what we know. We know that we have 10 students total in kindergarten, and we also know that 3 of those 10 are boys. So what we're going to do is subtract those 3 boys from the 10 total students to give us the difference, which will be the total number of girls that we have in kindergarten. So now we're going to go ahead and work this out. So 0 ones cannot take out 3 ones. So we're going to have to regroup here, take away the 10, leave it with 0, and then we're going to have 10 ones now. So 10 ones minus 3 ones gives us 7. So now we know that there are 7 girls in kindergarten. Okay? So let's take a look at this relationship using strip diagrams. Alright, so here we are. We have here are 2 strip diagrams. Okay, we know the total amount here is 10 students. So one of our strips shows 10 students because we know that our total number of students in kindergarten is 10. We also know that 3 of those 10 are boys. So this is about 3 out of the 10. And those are 3 boys. So now we're going to add in our 7 girls. Alright, that we figured out in our subtraction problem. So now we can see by our strip diagrams that 3 boys and 7 girls gives us the total number of students in kindergarten, which is 10. Alrighty, awesome. Now we're going to take a look at our next problem. Okay. Problem 7 says, Summer has some shoes. She gets 4 more. Now she has 12. How many shoes did Summer start with? Alright, so again, I've listed the 4 different structures that we could possibly use to help us work this problem out. And we're going to decide which one will best suit the needs of this problem. Okay, so separate. Are we taking anything out of our starting number? By reading this problem, I know that no, we're not taking anything out or separating out any amount, so it's not going to be separate. Part, whole. We're not discussing any 2 parts here, so that's not going to be it either. Alright, compare. We're not comparing any 2 items here, so we're not going to use compare. Which leaves us with join. Join is used when we have our starting number and we're joining in some more. And we know that she had some amount, she gets 4 more, or joined 4 more into her starting number, and then she had her ending number or her result. So for this problem, we're going to use the join structure. Okay, and again, I have one that we're going to write on and work out on here. Okay, so the first thing we're going to do is uncover the problem structure using the join structure. Okay, awesome. So we know that Summer started with some amount of shoes. Okay, so right now we don't know what she started with, but we can go ahead and fill this circle out with a question mark. Okay, because we do know that this is what we're going to be looking for in this problem. Okay, so Summer had some amount of shoes. She gets 4 more. So we know that the change in this problem is going to be 4 because she gets 4 more, or she joined 4 to her starting amount. Okay, and it says now she has 12. So we know that she had a certain amount. She got 4 more, which then gave her 12. So we know the result of her shoes is now going to be 12. So we're looking for how many shoes Summer started with. Alright, So we know the change made, we know the result. So now we need to figure out how we can find the starting number. Well, if we take our result and subtract the 4 because it was our change, then this will give us our starting point. Because if we have our starting point and joined in our 4, we are adding here, which will give us our total. So to get the starting, we'll do the opposite of adding, which is subtracting. So we're going to take our result, which is 12, and then we are going to subtract our change, which is 4. And now we are going to work this problem out to find our starting number of shoes. Okay, so 2 ones cannot subtract 4 ones from itself, so we're going to have to regroup here, take the 110 away, and now we're going to give 10 ones to this 2, which gives it, or which makes it a 12. So now we have 12 ones, and we're going to subtract 4 ones from that, which is, that's right, it's 8. 12 minus 4 gives us 8, which means that the number of shoes that Summer started with was 8. And we can check this problem by going through the process here in the join structure. So if Summer started with 8 shoes and the change that occurred was her joining 4 more, we know that 8 plus 4 gives us 12. Yep, and when we take a look at our result, we know that the result was 12, and there we go. We know that Summer started with 8 shoes. Now we can take a look at this using strip diagrams by drawing it out. So now we're going to draw out our 2 strip diagrams. Okay. 1 strip diagram. 2 strip diagrams. So we know that our result is 12, so we're going to add our total number of shoes here to be 12. So 1 full strip diagram equals 12. And then we're going to fill out our second strip diagram by inputting our 8 that we started with. So here's 8 shoes. Okay, so now we have 8 shoes here, and the second part will be our change, or our join in this case, and that will be 4 shoes. So by looking at our strip diagram, we can see the relationship here. 8 shoes joining 4 shoes is the same as having 12 shoes. Alright, awesome. So we just took a look at 4 different types of structures, and we know now how to uncover different types of problem structures, and we know how to represent the relationships between different quantities using strip diagrams.